All right, in this question, we'll go ahead and look at number 4, that says, recall the chain rule in section 13.5. If z is equal to a function f of xy, and x and y are functions of t, then we can compute the derivative of z with respect to t as del z del x times dx dt plus del z del y times dy dt. How is this related to our formula for the differential? All right, well, first, let's go ahead and write down our formula for the differential up here. So this was just from that last video. So dz was what? Well, in that video I wrote f sub x, but to connect it with this expression here for the chain rule, I'm going to go ahead and write it using del notation. So this would be del z del x times dx plus del z del y times dy. And I think writing it this way really just makes this result for the chain rule almost trivial, right? Because what is the chain rule all about? Well, it's measuring a rate of change of z with respect to this parameter t. And this differential is really just measuring the change in z itself, at least on the differential level, right? So really all we're doing here, thinking about going from this differential statement to the statement for the chain rule, is simply think about dividing now by the change in t, right? So through this division, right, we're really just saying, well, dz dt is then what? Well, we would have our del z del x, and then the dx, right, is being divided. So this is now really a rate of x with a rate of change of x with respect to t, and then likewise here, del z del y times dy dt. Okay, so very, very similar there. I just wanted to connect those two key ideas. That's going to do it for this video.